Hello students, so we are here with our next video. In our last video, we had discussed about the general organization of the plasma membrane. We had also discussed about the components of the lipid component of the plasma membrane. Today, in this video, we're going to discuss in details about the lipids. So let us start. So in our last video, I had discussed that lipids, the membrane lipids, has the following components. Number one, phospholipids. Number two, sphingolipids. Number three, archaeal ether lipids. And number four, sterols. So we are going to first discuss about phospholipids, right? So phospholipids are any lipids containing the phosphate group or PO4 twice minus. Now, before we get into phospholipids, let us just give you the general idea or the general structure of phospholipids, and then we are going to discuss the different types of phospholipids. Now, phospholipids has the most important type of phospholipid. I mean, see, phospholipids also has certain subtypes, but out of these subtypes, the most important type of phospholipid, okay, is called glycerophospholipid. Glycerophospholipid means that it is a phospholipid having glycerol. Now we are going to discuss what glycerol is, and we are also going to see how phospholipids are connected to them. Okay, so let us rub the rest and focus solely on phospholipids. Now, what we are going to discuss now is basically glycerophospholipids. What exactly is glycerophospholipids? Now, phospholipids having a backbone of glycerol. If they have a glycerol backbone along with two fatty acid chains this way, it is attached to the glycerol backbone this way, and as the name suggests, it is also a phospholipid. So another phosphate group attached to the glycerol molecule along with a head group X. Okay, so this is the general structure of a glycerophospholipid. Now I'm going to tell you what X is. I'm going to tell you what fatty acids are. Let us break it down one by one. All right, let us break it down one by one. Now, first and foremost, when I say fatty acids, what exactly do you understand? What exactly are fatty acids? Fatty acids, what exactly is the structural basis of fatty acids? Now, basically, fatty acids are nothing but long chain carboxylic acid. Now, if you remember, what exactly was carboxylic acid? RCOOH, right? That is the general formula of carboxylic acid. Now, if for some reason this R happens to be very long, okay, happens to be around 16 to 18 carbons long, okay, around 16 to, not exactly 16, it would be wrong to call it just 16. Say this R group is 10 to 20 carbons. Okay, this R group is 10 to 20 carbons long. Then basically this is a fatty acid. All right. So if I have to draw a fatty acid, first and foremost I'm going to draw this. I'm going to draw this. Okay. So a carbonyl group and OH group. Right. Now along with this carbon, I'm going to draw a chain of hydrocarbon this way. So how many carbons are there? Just see. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So a minimum of 10 carbons. Okay. Now, if there are no double bonds, if there are no double bonds in this carbon chain, then this means that this is a saturated fatty acid. Okay, saturated fatty acid means that in this carbon chain there are absolutely no double bonds. Now, if I draw a fatty acid, okay, just a second. If I draw a fatty acid this way, OH, right? Now from here I'm drawing the hydrocarbon chain, right? How many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Now, in somewhere in this 12 carbon chain, if I just give a double bond here, okay? So there is a double bond present, right? So this means that this is a unsaturated fatty acid. Okay. So the presence of double bond means unsaturated. Absence of double bond means basically saturated. Okay. So this is the general structure of fatty acid. So this basically, these structures are nothing but the fatty acids. Right? This is the fatty acid. Fine. Now let us see glycerol. Now we are going to see both fatty acids and glycerol, and then we are going to combine it all together, and then we are also going to see phosphate, and then finally we are also going to see what X is, right? So we are going to dissect it part by part. So I hope this part is clear. Now, the next part, glycerol, right? So, what exactly is glycerol? So, glycerol is a molecule having 3 carbons. There are 3 carbons associated with glycerol, and on one side of each carbon, there is a OH group. This way, okay, and on the other side you have H, right? So this will have CH2, CH2, just balancing out the tetravalence. That's all, right? So this is basically glycerol, right? Now, if I add a fatty acid to one of the carbons of glycerol, what will happen? If I add a fatty acid to one of these carbons, right? So how will the molecule look like? Okay. So suppose this is a fatty acid here. Okay. Let me draw it a bit closer. Okay. This is a fatty acid, right? Right? This is a fatty acid. So, if I say that this hydrogen, okay, this hydrogen and this OH group, right, escapes by the formation of water, okay, the H from the glycerol and the OH from the fatty acid, right? So, if it escapes, right, if it escapes by forming water, then what is going to be the net result? Right, what is going to be the net result? The net result will be, I'm just drawing it a bit closer. The net result will be this, right? So a fatty acid has been added to a glycerol molecule. How? By formation of a bond in the expense of water, right? So what do you call a reaction? Okay, what do you call a reaction which has water as a byproduct? We call such reactions as condensation reaction. So this is an example of condensation reaction. All right. Now, here you see, in this particular molecule, this is a glycerol having one fatty acid, right? So this molecule will become mono because it's one, acyl means one fatty acid. So monoacyl means one fatty acid glycerol. Monoacyl glycerol, right? Now, if this happens, if I add another fatty acid here, right? Then what will happen here? This will be diacyl glycerol. And if I add another one here, okay, then this would have been triacyl glycerol, right? Now, when it comes to phospholipids, okay, then what happens is that here, all the 3 carbons do not have fatty acids. Rather, only 2 have fatty acids, and the third one, okay, they have what? They have the phosphate group. Remember, I told you there is another phosphate group available also, right? So they have a phosphate group this way, right? So no, this will have the negative charge here, okay? And there is an X. X is a variable. I'm going to talk about X in a short while. So now this is basically the composition of a glycerophospholipid. I've just shown you how a glycerophospholipid is formed. So glycero, why? Why glycero? Because of the backbone of glycerol, right? Why lipid? Why from where does the fatty acid come? These 2 fatty acids. Remember, I told you in the previous diagram I've showed you there are 2 fatty acids, and also there is a phosphate group. PO. Just a second. PO4. Yeah, sorry. Yeah. PO4 twice minus, right? So that is basically phosphate group, right? Now, how do you relate this to the diagram that I gave you, right? I've given you this, right? But when I draw lipids, I draw this way, correct? Right? So which one is what? This is actually this, right? So this entire diagram is actually this. So which one is what? How do you know? See, remember, this portion right here is the head, right? And this entire thing is the tail, correct? So, out of this portion, which is the head and which is the tail? The tail is this portion, this entire fatty acid chain. These 2 are the tail. This is the tail. So there are 2 fatty acid chains here, and there are 2 fatty acid chains here. So this is the tail, right? And this remaining portion, excuse me, this remaining portion, okay, this remaining portion, it is the head, okay, this is the head. So now you have a clear idea of what exactly is a lipid, right? I'm just giving you the example of glycolipid here, the glycerophospholipid here. So this is basically the basic diagram. At your level, you do not need anything more than this, okay? So kindly just go through this once, okay? What exactly is glycerophospholipid? Just go through it once. Now we are going to proceed to the remaining lipids, right? We're going to proceed to the remaining lipids, but before that, let me tell you what X is, right? So we missed the important part. What is X? Okay. Now, X is a variable, all right? X is a variable, okay? Now, depending upon what X is, right? Depending upon what X is, this molecule will have different names, okay? This entire molecule, the name of this entire molecule will depend on what exactly is this X, right? So, for example, if X is H, right? It means that in place of this X, I'm going to write simply hydrogen, all right? If in place of X, we have H, then the name of this entire molecule will become phosphatidic acid, okay? This entire molecule will become phosphatidic acid. And phosphatidic acid is the simplest glycerophospholipid, okay? It is the simplest glycerophospholipid. So if X is H, then the entire molecule is called phosphatidic acid, okay? If X is choline, there is a molecule called choline here, it's an alcoholic molecule. If X is choline, then the entire molecule will become phosphatidyl choline, alright? If X is serine, serine is an amino acid, okay? Serine is an amino acid. If X is serine, then the entire molecule will become phosphatidyl serine, right? So these are certain examples. Depending upon the depending upon the identity of X, the identity of the entire molecule will vary. If X is simply hydrogen, then what will happen? The molecule, the entire molecule will become phosphatidic acid, right? I'm talking about glycerophospholipids, okay? If the X is choline, then phosphatidyl choline. If X is serine, phosphatidyl serine, and there are many more. I can give you I'll give you a PDF later regarding. I'll give you a table that will be for your reference. But this is the general perception, right? So I hope this portion is clear, because now what we are going to do, we are going to discuss about the remainder of the lipid portions. And I'm not going to discuss much of the structure. I'm just going to give you a few information. At your level, you do not need much, right? But it was very essential for you to understand this portion, right? Just to give you a general structural idea, right? That was very important. Okay. The next type of lipid was sphingolipid, right? We have discussed phospholipid. Now this is sphingolipid. Now, what exactly is sphingolipid? Sphingolipids are lipids having a backbone of a molecule called sphingosine. Okay. The backbone of a molecule called sphingosine. Along with this backbone, okay, along with this backbone, there is one molecule of fatty acid, okay, okay, and there is one polar head, right? Remember, the glycerophospholipids also had a head region which was different, right? So this polar head can be phosphate, right? It can also be glucose, okay? Glucose or galactose, okay? So glucose or galactose, it can be both. It can be either of them, okay? So a polar head. So sphingosine, just to give you an idea, sphingosine has one fatty acid, right? So when we draw sphingosine, this entire thing, actually the head region is this backbone along with the polar head, right? So this entire thing is the head. So I'm going to draw the head here, right? And the tail is just one single fatty acid. So the tail will be simply one, right? In glycerophospholipid, we drew two tails because there were two fatty acids. But in case of sphingolipid, there's simply one fatty acid. Okay. Then we are going to discuss about archaeal ether lipids. Okay. Archaeal ether lipids, basically they are found in, I'm just going to give you the information, that's it. They are found in archaebacteria. Okay, this is the most primitive kind of bacteria. Why is it found? What specialty does it have? First and foremost, archaebacteria resides in very harsh climatic conditions. Okay, they are mainly found in volcanic places, right, and so on. Volcanic places, high temperature, low pH. So their entire plasma membrane constituent is different. Okay. Now, the primary function, the primary difference is that the fatty acid chain, is much longer, right? Usually there are 10 to 20 carbon fatty acids, right? In our normal fatty acid chain, there are 10 to 20 carbons. But in case of archaeal ether lipids, there are approximately 32 carbon fatty acids. Okay, there are approximately 32 carbon fatty acids, right? There is a special molecule, right? There is a special molecule called GDGT. Okay, glycerol diether, glycerol dimethyl glycerol tetraether. Okay, glycerol dimethyl glycerol tetraether, GDGT. It is a unique molecule which is found in archaeal ether lipids. Okay, so this is basically the general idea of archaeal ether lipids, and the last portion of lipids is sterols. Sterols, right? So sterols have a common formula which I have shown you previously, right? So there are essentially 4 fuse rings this way. So 3 6 carbon rings, okay, and 1 5 carbon rings. Okay, so these fuse rings are basically called steroid nucleus. Okay, these are basically called steroid nucleus, and from this steroid nucleus there are various different types of steroids that can come. For example, cholesterol, sitosterol, stigmatosterol, right? So all these steroids have a chain this way. Okay, so here in this entire section there is a OH group, right, which is the head. Okay, this is the head, and this entire thing, right, this is an alkyl chain, right? We're going to discuss it when we discuss about the biochemistry of sterol, right? This entire thing is the tail, right? So what is the speciality of sterols? What it does, sterols, they hinder the movement of plasma membrane, which we are going to discuss later. Okay, we are going to discuss about the fluidity of plasma membrane. Rather than writing movement, we can write, okay, this, there is a more proper term for this, okay, hinder the fluidity of plasma membrane. So we have discussed about the different types of lipids found, right? Now next in our next video we're going to discuss about the different proteins found, right? Different types of proteins which are found, and subsequently also different carbohydrates which are found. Okay, thank you for your time. I hope you found it simple enough to understand.